Databases are essential for organizing and managing information. They store data in tables with rows and columns. Good database design ensures data integrity and efficiency. This is where database normalization comes in. It is a fundamental process in database design. Normalization helps to organize data efficiently. It reduces data redundancy, which is the unnecessary repetition of data. It also ensures data consistency, meaning data is accurate and reliable. By following normalization rules, we can create well-structured databases. Database normalization is a design technique. It organizes data into multiple related tables. The goal is to reduce data redundancy and improve data integrity. It involves applying a set of rules called normal forms to database tables. Each normal form has specific criteria. These criteria address different types of data anomalies. The most common normal forms are first normal form, second normal form, and third normal form. Higher normal forms exist but are less frequently used. First normal form is the first step in normalization. It sets the foundation for a relational database. A table is in first normal form if it meets the following criteria: atomic values. Each column should contain only atomic values. This means each cell should hold a single indivisible piece of data. No repeating groups. There should be no repeating groups of columns within the table. Consider a table called customers with columns for customer ID, customer name, and products purchased. If the products purchased column contains multiple product names separated by commas, it violates first normal form. To achieve first normal form, we can create a separate table for products and link it to the customers table using a foreign key. This eliminates repeating groups and ensures atomic values in each column. Section 4. Second normal form, or 2NF. Second normal form builds upon the first normal form. A table is in 2NF if it meets the following criteria. It is in 1NF, and non-key attributes are dependent on the primary key. This means all non-key attributes, which are columns that are not part of the primary key, should be fully dependent on the entire primary key. Let's say we have a table called orders with columns for order ID, customer name, and product ID. The primary key is a combination of order ID and product ID. However, customer name is only dependent on customer ID, not the entire primary key. To achieve 2NF, we can move customer name to the customers table, where it is fully dependent on the customer ID primary key. This eliminates the partial dependency and ensures data integrity. Section 5, third normal form, or 3NF. Third normal form further refines the database structure. A table is in 3NF if it meets the following criteria. It is in 2NF and there is no transitive dependency. This means no non-key attribute should be transitively dependent on the primary key. In other words, a non-key attribute should not be dependent on another non-key attribute. Suppose we have a table called employees with columns for employee ID, department ED, and department location. The primary key is employee ID. However, department location is dependent on department ID, which is itself dependent on employee ID. To achieve 3NF, we can move department location to a separate table called departments, where it is directly dependent on department ED. This eliminates the transitive dependency and further improves data integrity. Section 6. Benefits of database normalization. Database normalization offers several benefits, including reduced data redundancy. By eliminating repeating data, normalization optimizes storage space and improves data management. It also improves data integrity, ensuring that data is consistent and accurate across the database. Additionally, normalization simplifies data updates. With normalized data, updates are easier to implement and less prone to errors. Enhanced data consistency is another benefit. Normalization prevents data anomalies and ensures that data is reliable and trustworthy. These benefits contribute to better database performance, easier maintenance, and improved data quality. Section 7. Conclusion: achieving data integrity and efficiency. Database normalization is an essential aspect of database design. By understanding and applying the principles of 1NF, 2NF, and 3NF, we can create well-structured and efficient databases. Normalization helps to reduce data redundancy, improve data integrity, and enhance overall data quality. By following the rules of normalization, we can ensure that our databases are reliable, efficient, and capable of supporting the information needs of organizations. Normalization is a fundamental practice for anyone involved in database design and management.